Okay. An ellipse is a set of points on a plane where the sum of the distances from a point to two fixed points is the same, and it's a constant. So basically, from A to F1 plus A to F2 equals B to F1 plus B to F2. That's your constant. And F1 and F2 are the foci or foci, and singular they're the focus tube. Okay, next we have, this is a vertical ellipse. What we just looked at was horizontal. So you know that it's vertical because this major axis is the bigger of the two axes, and your focus points, your foci are on your major axis, and the points at the end of the major axis are the vertices, vertexes, whatever, and then the center is at the middle, yeah. And then the smaller axis is the minor axis, and the points at the end are the covertices. The standard formulas for a vertical ellipse are x squared over b squared plus y squared over a squared equals 1. And you know that your vertices are 0, plus or minus a for vertical ellipses, and your foci, whatever they are 0, plus or minus c on the y-axis. And these should be on the same axis. And then your covertices are plus or minus b, 0. And that's all for vertical. And then for horizontal, your standard equation is x squared over a squared plus y squared over b squared equals 1. Notice how a and the b just switch from vertical to horizontal. And then your vertices for your horizontal ellipse are plus or minus a, 0, and your foci are plus or minus c, 0 on the x-axis. See, they're in the same spot. And then your covertices are 0, plus or minus b. And all of this is literally just the reverse of this. You always know which one is A and which one is B, because A is always bigger than B and B is always bigger than 0. And you can always find C by using almost the Pythagorean theorem, but it's c squared equals a squared minus b squared. Okay, first problem. Find the equation of the ellipse using your vertices at 2, 0, your covertices at 0, 1, and the center at the origin. Now, first you can sketch this out with your vertices at 2, 0, 2 on each side, and then covertex 1 and 1. And you know that it's horizontal even before you sketch it out, because looking back at your formulas, these standard formulas for your vertices and covertices match up with how it should be for a horizontal ellipse. So now you're going to plug in these numbers into your standard equation. Picture it as this. And this is your final equation, because A is 2 and B is 1. Voila. Okay.
Let's wait here for a second.
How beautiful is that? Okay. Next, you are going to graph an ellipse and find the foci using this equation, 4x squared plus y squared equals 36. And the first thing you're going to do is divide everything by 36, so you can put it into standard form, equaling 1. So divide everything by 36, and you get x squared over 9 plus y squared over 4 equals 1. So that's almost in standard form, and to put it in one more step to make it look even more obvious, you do the square roots of those, so it looks literally identical to your standard equation. So you have x squared over 3 squared, so 3 square root of 9, and then plus y squared over 2 squared, 2 square root of 2, 4, 2 squared root of 4, and then it equals 1. So that's your standard equation, and you know that it is horizontal because A is always bigger than B. So you lost words.
Graph.
Graph, thank you. You put it into the graph, and you know your covertices are at 2 because covertices are B. So you go at 2 and 2. And then your vertices are at 3. So you put them there, and then you have your little ellipse, and it's actually horizontal. And then to find your foci, you plug in the numbers that you have to c squared equals a squared minus b squared, and since that's a and that's b, so then c squared equals 9 minus 4, so c squared equals 5, and then you take the square root of that, plus or minus, and so your foci is plus or minus square root of 5 comma 0, and that's roughly a little more than 2, so you plug those in there, your little foci, and then you've done it. Beautiful. And then you find the equation using your foci at 0 comma plus or minus 8, and your co-vertices at plus or minus 8 comma 0, and you know automatically that this is a vertical ellipse because your points that you're given match up with the formulas you're given in the standard formulas. Yeah. So, first thing you're going to do is find A, since you're given B and C. B and C. And since they're both 8, it's just 8 squared equals A squared minus 8 squared. C squared minus B squared equals, C squared equals A squared minus B squared. So then to isolate the variable, the A, you're going to add 8 squared to both sides. And then you see 64 plus 64, aka 8 squared plus 8 squared, equals A squared. And then that's 64 and 64 make 128. And to find A, you're going to take the square root using plus or minus. And then since now you know A and B, you can plug it into your equation. Because A, since this is vertical, A is square root of 128 squared, and then 8 squared. And that's your equation. Beautiful. And finally, you have to write an equation using this graph of an ellipse. And you see that it goes through point 0, comma 2 and point 3, comma 0. And you know that this is your major axis and these are your vertices because A is always bigger than B. So you know it's horizontal. It looks horizontal. And so A is 3, because that's where that point is, and B is 2, so that's where that point is. So you just plug in those numbers to your standard equation where A and B are, and that's all that you need. And this has been Ellipses.